In the last class, we were discussing real numbers, and in real numbers, we have learned multiple things. I have told you about the prime factors, composite numbers, about the fundamental theorem of arithmetic. Okay, and we have discussed that how we can prime factorize a number. Okay, so these things we have discussed in our last lecture. We have covered everything. So today, let's discuss this very good question that 4 to the power n can never end with 0. Okay, these things we have discussed in the last class. So today, we are going to discuss about the LCM and HCF of numbers using the prime factorization method. Okay, as you know that from basic classes you are aware of that how to find LCM and HCF of two numbers. Okay, two numbers, three numbers, any numbers you have given, you can find the LCM and HCF of those numbers. Okay, so today I am going to teach you that how we can prime factorize a number using that how we can find numbers LCM and HCF. Okay, so first of all, what is LCM and HCF? Let's do revise something. What is LCM? Least common multiple. Common multiple. Let us say we have two numbers A and B. Okay, A and B. So the numbers which come in the table of A and B, okay, or numbers which are get divided by A and B. Suppose 2. So which are the factors of 2? That is 2, 4, 6, 8. And let us take 3. That is 3, 6, 9 and 12. So least common multiple. The first common multiple, smallest common multiple of the both numbers is called the LCM of those numbers. Okay, so this is the basic definition of LCM. Now, if we discuss about HCF as well, then HCF is called highest common factor. You are very well. Okay. So in which, suppose there are two numbers A and B, then greatest number which divides A and B both is called the highest common factor of those numbers. Suppose we have two numbers 12 and take a number 18. Okay, so which are the factors of 12? We have 1, 2, 3, 4, 6 and 12 itself. And for 18 we do have 1, 2, 3, 6 and 9 and 8. So which is the greatest number which divides both 12 as well as 18? So as you can see here that 6 is the greatest factor of the both numbers. Okay, 6 divides 12 as well and 6 divides 18 as well. There is none other number greater than 6 which is dividing both the number. Okay, so I think both concepts are clear in your mind, and these are the concepts you have studied in your previous classes as well. So I just wanted to get you a quick revision. Now we are going towards our concept by using fundamental theorem of arithmetic, how you can find out the LCM and HCF of two numbers. Okay, so this is a very interesting concept, and once you learn this concept, you will get the LCM and HCF of two numbers really easy. Okay, so let us take these two numbers only and try to find out the LCM and HCF of these numbers. Okay, so first of all, 12. Okay. So 12 and 18, we do have two numbers and we have to find out the LCM and HCF of these two numbers. Okay. So as we know, we can prime factorize this using, let us see, we can write it down as 4 into 3. Okay. 4 into 3. Break down our number. Okay. As simply as you can. Okay. And now break it until you reach till the prime factorizations. Okay. So 12 can be written as 4 into 3. Now 4 can be written as 2 square into 3. Now 2 is also a prime number and 3 is also a prime number. So we have reached till our prime factorizations. Okay. Similarly, we will see also for larger numbers as well. Okay. Now for 18. 18, we can write it as 2 into 9 and this is equals to 2 into 3 square. Okay. So here we do have 2 square into 3 and below the prime factorization of 18 is 2 into 3 square. Now we have to find out the LCM and HCF of these numbers. So while finding the HCF, take out the common factors in both the numbers. Okay, which are the common factors in both numbers? You can see that 2 is in the both numbers prime factorization and 3 is also in the both numbers prime factorization. Okay, so and now after finding out the common factor, take out the least common power. Okay, here we have 2 to the power 2 and here we have 2 to the power 1. So what is the minimum common power of both? That is 2 to the power 1. And again for 3 as well, you can see that 3 is the common factor in both the numbers. Okay, so above 3 to the power 1 and below 3 to the power 2. So what is the minimum common power which is in both? That is 3 to the power 1. So that is the HCF of these numbers is 2 into 3, that is 6. Okay. So by normal method, you have also seen that 6 is the greatest number that is dividing both 12 and 18. So by this, again I am repeating. First of all, find out the common factors of both the numbers. Okay, find the common factors of A and find common factors of B. Suppose if we have more than two numbers, then we will also do the same process. We will find out the common factors. In each prime factorization, we will find out the minimum common power. Okay, once we complete this process and take out the prime factorization and multiply them, we can get our desired effect. Okay, now while finding LCM. Okay, so for LCM again, you have to include all the factors, not common factors, all the factors. Okay, so here in 12 you have two factors 2 and 3 and in 80 we have two factors 2 and 3. Here it's just a coincidence that both the factors are common. In some places, in some numbers, there can be some factors which are not common. But you have to take all the factors. Okay, we will see some examples. So here we do have 2 square into 3 and 2 into 3 square. Now take all the factors 2 and 3 and take the maximum power. First checking the both prime factorization. What is the maximum power of 2? That is 2 to the power 2. And what is the maximum power of 3? That is 3 to the power. Okay, so this is 2 to the power 2, that is 4, 9, 9, 4 is 36. So we have the LCM, that is 9 into 4, 36 is the LCM and 6 is the HCF. As you can check, 12 3 are 36 and 18 2 are 36. So 36 is the number which is divided by both, and it is the smallest number, which is multiple of both numbers. Okay, so here we have seen how we can find out the LCM and HCF of two numbers using the prime factorization method. Okay, this must be extremely clear. And now let us go to our book and try to check, okay, what the things are mentioned there. Okay, so similarly, here you have already learned, okay, these things. Now here they have taken two numbers, 6 and 20. Okay, now for 6 the number is 2 into 3. Okay, prime factorization 2 into 3. And for 20 you can write it down as 20 to the power 20 as 4 into 5, and then 4 into 2 square into 5 to the power 1. Now, why taking HCF? Which are the common multiples? You can see here 2 is the common. And what is the minimum power of 2 which is common in both? 1. Okay, because here 2 to the power 1 and 2 to the power 2. What is the minimum power common? 2 to the power 1. That is the HCF. And finding LCM. So, here you can see 2, 3, 2, 5. Okay, so you have to take all the common factors. So we will take 2, 3 and 5. Okay, now the maximum powers. What is the maximum power of 2 in both the prime factorization? That is 2. What is the maximum power of 3 in both the prime factorization? That is 1. And what is the maximum power of 5 in both the factorization? That is 1. Okay, so I multiply these, we can see that we have decapsulate like this, our factorization at LCM and HCF. Okay, now let us discuss one example for three numbers as well, as some students might get confused. So let us discuss for three numbers, as after that you can follow it for any numbers you want. Okay, so now let us take three numbers, that is any numbers. Suppose we have one number 50, okay, one number suppose 20, and one number that is we can write it 28. Okay, these three numbers, arbitrary numbers, 7 numbers you can pick of your choice. Okay, and first we will prime factorize it. So first is very near 5 into 3. Second we write it down as 5 into 4. Then we can write down it as 5 into 2 square. And for 28 we can write it down as 4 into 7. Then we can write it down as 2 into 7. Okay, so our prime factorization is done, because in each you can see that in first 5 and 3 are prime numbers. Here 5 and 2 are prime numbers. There 2 and 7 are prime numbers. Okay, absolutely clear. So let us move forward and find out what is our HCF. Okay, HCF of 15, 20 and 28. So take out the common factors. What are the common factors? Yes. So we have common factors. 5 here, 5 is here, but 5 is not here. Okay, we do have 3 here, but we do not have 3 here. We do have 7 here, but 7 is not. So we don't have any common factors. Okay, so in such case, what is our HCF? That is, okay, when nothing is common, we have 1. And for LCM, you can check out, there is none other number than 1 which divides all the 3 numbers. Okay, so that's what we have discussed here. Now, for LCM of 15, 20 and 28 here. Okay, so here we can find out that while taking LCM, we can take first of all common all the factors, write down all the factors. 2 is a factor here, 3 is a factor, 5 is a factor, and 7 is a factor. Write down all the prime factors occurring in all the numbers. Okay, we are write down 2 is there, 3 is there, 5 is there, and 7 is there. Now write down the maximum powers. Okay, write down the maximum power. So what is the maximum power of 2? Here also 2 to the power 2. Here 2 to the power 2. 2 is not there. So maximum power is 2 to the power 2. Okay. Now, what is the maximum power of 3? 3 to the power 1. 3 is not in. So what is the maximum power of 3? That is 3 to the power 1. Now, what is the maximum power of 5? That is also 1. Okay. Now, what is the maximum power of 7? This is also 1. So this is basically 2 to the power 2. 7. So we can write it down as 35. So we can write it down 4. 20 is the answer. Okay. So I think this must be extremely clear in your mind. Okay. So using prime factorization, we can find out the HCF and LCM of our numbers very easy. Okay. And within a seconds. Okay. If you don't have your prime factorization, within seconds you can find out. Okay. So now, from now onwards, you have to do your HCF and LCM not using those. Okay. Those tricks. Try to avoid. Because now the examiner expect you using some advanced methods. Okay. We have a very beautiful result again from HCF and LCM. Okay. What does this result say? Suppose if we have two numbers A and B. Okay, we have two numbers A and B. So now, if we see, then HCF of AB into LCM of AB is equals to A cross B. Okay, so if we have two numbers, then product of those numbers is equals to product of their HCF and their LCM. Okay, we can check it as well. Okay, we do have find out the HCF and LCM here 12 and 18. Okay, so let's write it down. 12 and 18 were our numbers. Let A is equals to 12 and B is equals to 18. We have also find out LCM and HCF. Okay. So what was the LCM? LCM was 36 and HCF was 6. Write it down. LCM was 6 and HCF was 36. Okay. So if we do check, then A cross B, this is equals to 12 into 18. And 12 into 18, that is 260. Okay. So this is A cross B. Now, LCM into HCF, that is 6 into 36. So both sides you can see here also 216 and here also 216. Okay, so this is what our numbers are saying, that LCM and HCF of two numbers, their product is equals to the product of those two particular numbers. Okay, let us check. In our book, this thing is also mentioned, Okay, here you can see that HCF and LCM of two numbers is equals to A cross B. Okay, here we have given some numbers 96 and 404. So using that, just a second. LCM of 96 and 401, and by using the number formula, find out their LCM. Okay, so let's do this question. 96 and 404. Okay, so A is 96 and B is 40. But we have to find HCF. Okay, then now using our formula which we just have discussed, that LCM into HCF is equals to product of those numbers, we have to also find out their LCM. Okay. So again, we can write it as 12 into 8. Now 12 we know that 4 cross 3, and 8 that is 2 to the power 3. And this is equals to 2 square into 3 into 2 cube, and powers at, okay, 2 to the power 2 plus 2 to the power 3, that is 2 to the power 2 plus 3 into 3, that is 2 to the power 5 into, okay, powers of prime factor. Somewhere, suppose if we do have a to the power x into a to the power y, a to the power x plus y, and divisor a to the power x upon a to the power y, this is equals to a to the power x minus. Okay, so these things you have studied in your previous classes. Okay, but I have clarified. Okay, so let's move on. So prime factor of 96, we do have 2 to the power 5 into 3. Now this we can write it down as 4 into 101. Okay, 4 into 101. Now 101 is itself a prime number. Okay, so because this number is not divided by, you can check. Okay, you can check this is not divided by 2, 3, any number. You can take this number is not divided by any number. Okay, so we can write it down as 2 square into 1 0. So here 96 can be written as 2 to the power 5 into 3, and 404 can be written as, what can we write it as? 404 2 square into. So HCF of these numbers, common factors, we do have 2 to the power. So HCF is 4. Okay. Now, while writing LCM, what we do have? That LCM of AB into HCF of AB is equals to A cross B. Okay, we know this formula. Now, we can use it here. That LCM of two numbers, we have to find out LCM. HCF, we have find out. And what is the product? That is 96 40. So LCM is equals to 96 into 404 on 4. This is 101. So 96 into 101. When you multiply it, you can find it out. I think 96096 will be the answer. We can put it and check. 101 into 96. So this is equals to 606 into 909. So you can find it out. And 6 times 6. So this is enough. Our first. Okay. So here we have discussed that how we can find out the LCM and HCF of two numbers using prime factorization. Here you can see those numbers were big. Okay. But by breaking into prime factors, we can easily reach our result. Okay. So here, I think these things will be extremely clear. Now, let us move towards what we are discussing. Yes. Okay. So today we will complete our class till here. Okay. Now in the next class we will discuss further the leftover things, and in the next class we will complete our chapter LCM and HCF. Okay. So I hope you do have liked what we have discussed in our class, and if you do have any doubts and you want to study further with us or want to connect with us, you can reach on to our website, GoAskNow. Okay. Thank you so much.